If we hold a page of a book in front of a mirror, we see laterally inverted letters in the mirror. Why does this happen? When light rays traveling from the letters fall on the mirror, they get reflected. Image of every point on the letters is formed behind the mirror at the same distance from the mirror as the point itself. This we have already seen. And this produces lateral inversion. Hence, we see laterally inverted letters in the mirror when we hold a page of a book in front of the mirror. Which letters of the English alphabet form images that look the same as the original letters? The letters of the English alphabet that form images same as the original letters are A, H, I, M, O, T, U, V, W, X, Y. You can observe this on your own. Okay, next, use your brain power. When a so the image of a word appears laterally inverted in the mirror, and the image of every point on the word is formed behind the mirror at the same distance from the mirror as the point itself, and this is called lateral inversion. Let us take this question. When a person stands in front of a plane mirror, how is the image formed and what is the nature of the image? When a person stands in front of a plane mirror, rays from his body fall on the mirror and get reflected, and thus they obey the law of reflection. Image of every point on the body of the person is formed behind the mirror, exactly at the same distance from the mirror as the point itself, and that is why this forms an erect but laterally inverted image of the person. The size of the image is same as that of the person. Okay, so what we need to remember, the size remains the same, only thing is there is a lateral inversion. Right becomes left. You can do this on your own and find out. Place two plane mirrors at an angle of 90 degrees to each other. Place small object between them. Images will be formed in both the mirrors. How many images do you see? If you have two pieces of mirrors, you can do this activity on your own and observe. The number of images that you will observe is 3. Now, if you change the angle between the mirrors as given in the following table and count the number of images each time, find out how is the number related to the measure of the angle and find the relationship. So, eventually, you find that you can calculate the number of images with the formula 360 degrees divided by the angle minus 1. So for example, if the angle is 120, so 360 divided by 120 is 3. So 3 minus 1 is 2. So the number of images formed between two mirrors, if the angle between them is 120 degrees, will be 2. Okay, so you can go on calculating for other angles with the same formula. Now, how big the mirror must be to form a proper image? Okay, let us find out. Distance from the mirror is irrelevant. Okay. Now let us go through this. In order to see the full image of a person standing in front of a mirror, the minimum height of the mirror must be half the height of the person. This is the basic requirement. So as you can see here, the point at the top of the head, H is for head, okay, and for eyes it is E, and for feet it is F respectively. R and S are the midpoints of HE and EF respectively. The mirror PQ is at a height of NQ, okay, and from the ground and is perpendicular to it. PQ is the minimum height of the mirror in order to obtain the full image of the person. RP and QS must be perpendicular to the mirror. Find out why by studying the figure. Minimum height of the mirror is PQ is equal to, the minimum height of the mirror is PQ is equal to RS, and we know that RS is equal to RE plus ES. Now this is equal to again HE divided by 2 plus EF divided by 2, which is HF divided by 2, okay. So this proves that in order to see the full image of a person standing in front of a mirror, the minimum height of the mirror must be half the height of the person. Spherical mirrors. You must have seen the mirrors displayed in the laughing chamber in a fair. Your face appears distorted in these mirrors. Why does this happen? These mirrors are different from the mirrors we have at home. They are curved. The images formed by curved mirrors are different from those formed by plain mirrors. Because of this, we do not see the familiar images in these mirrors. The rear view mirrors in cars, which enable drivers to see the vehicles coming from behind, are curved mirrors. Try this. Creation of spherical mirrors. If we cut a rubber ball into two parts as shown in the figure, we can see that each of the two parts has two types of surfaces. Generally, spherical mirrors are part of a hollow glass sphere like the part B in the figure. The inner or outer surface of this part is coated with a shiny substance to produce a spherical mirror. Reflection of light takes place either from its outer or inner surface. Thus, there are two types of spherical mirrors as described below. They are concave mirror and convex mirror. If the inner surface of the spherical mirror is the reflecting surface, then it is called a concave mirror. If the outer surface of the spherical mirror is the reflecting surface, then it is called a convex mirror.